Hello, Professor Hyun. Hello, class. I'm Howard, and my teammates, Andrew, Skylar, Brandon, and Juan, will be presenting our Android application called ServerMatch. So, what is ServerMatch? Our targeted audience are the small food businesses like your mom and pop taco shops that don't have dedicated applications to help serve their restaurant guests. Our application is a mobile cloud-based POS system which provides portability, multiple devices, and secure storage with Google Authentication. Some of our features are a database of their entire restaurant informations with restaurant menus like receipts for guests, quick updates from menu to cart. New menu items can be inputted and updated with different prices. We also provide menu filters, which each menu item will have tags and categories like spicy, vegan, dairy to help expedite the guest needs. The menu items can be filtered out to show only those tags selected. The server can easily help a guest figure out and match what their wants and needs are, hence the name we came up with, ServerMatch. Frequent customers and purchases. Our app stores and figures out their top recurring customers and what they usually purchase in case a server is new and doesn't recognize their VIPs. So what problem does ServerMatch solve? There are approximately 2.6 million servers within the US alone, and we would like to provide an app that would aid them in such a busy industry. We would like to provide a stress-free application so that they can provide A-plus customer interaction. Our focuses are efficiency, being able to access all their data fast and flawlessly. Accessibility, which is ease of use. Availability, our app should be operational 24/7 since we know some restaurants operate 24/7. Maintainability, we also would like to make updates frequent and easy to the app. User friendliness, we want this app to be almost self-explanatory where anyone on the job can just pick it up and use it, and also learn the features the more they use it. Next, I'm going to go over the architecture of ServerMatch with some diagrams. Here is our login state diagram. The user will first begin with the login state, then proceeds to enter in an email associated with the restaurant and password. The system will validate those credentials and move into the valid state or invalid credential states. The valid state will bring them into the menu, and then the invalid will ask again for either a different password or a different email. Here we have our add menu item state diagram. First, the user begins to log in, then the menu is displayed with the populated items in the display menu state, where the user can pick from the navigation drawer menu to add a menu item. The system will check if the menu item information is entered in correctly and then validate it. When everything is confirmed, the data will be stored in the Firestore database under the correct table. Here is the add customer state diagram. As you notice, this diagram is similar to the add menu item state diagram since it will emulate the same states and functions. Lastly, for our state diagrams, we have the menu state diagram. First, the user begins to log in, when then moves on to the display menu state. The bill state will be empty at first, and then as each menu item is added or deleted, the state will change accordingly. This will go on till the customer is ready to check out. For our last diagram, we have our NoSQL diagram. In our NoSQL diagram, we have a total of 5 collections and subcollections and 1 frequent customers class. Each restaurant will have their own subcollections of customers and menu items with a unique email for each restaurant. The restaurant collection has a one-to-many relationship with the menu item subcollection. Menu item subcollections specified by what each restaurant has on their menu lists. Each restaurant collection will have a one-to-many relationship with the customer sub-collection. There are attributes like the receipt email, which is a boolean, to determine whether or not the customer receives an email. A receipt text boolean determines whether the customer receives it by text. Each sub-collection will have a one-to-one relationship with the frequent customers class. The frequent customers class will handle everything locally offline on the device by Firestore document queries to customer collection. Each customer also has a many-to-many optional bill sub-collection. This bill sub-collection stores all receipts the customer has completed, which can later be emailed to each customer after each checkout. The menu items sub-collection will store the actual items purchased by the customer, which helps us keep track of the top menu items. I hope this gives a better picture of our software architecture.
Hello, I'm Skylar, and I will be going over the next section called Practices and Analysis. The first practice we'll be analyzing is user-friendliness. User-friendliness is important because it determines whether or not a user will interact with our app. On this slide, we used a user-friendliness quantifier. We rated ourselves 4 out of 5 stars and listed the pros and cons of why we think we deserve that rating. The first pro was that our user interface overall was easy to understand. Keeping the interface simple makes it easier to interact with and document. The second pro was that our UI does not overwhelm the user with too many options, which we believe is key to any UI. It keeps clear navigation between features and keeps with the clean and minimalistic aesthetic we wanted to achieve. As for the cons, we listed that it could improve on left-handed usage and incorporate more accessibility features. The next practice we will be analyzing is MVVM software architecture. MVVM stands for Model View View Model, where we create model classes, view classes, and view model classes. The purpose of MVVM architecture is to reduce the number of classes and keep the number of responsibilities minimal and well-defined. Proper MVVM tends to be used when retrieving data from a database, which we use in our app in order to keep the POS accurate and up-to-date. The images on the right-hand side show how we used MVVM in our Add Customer fragment and menu fragment. The next practice we will be looking at is GitHub. I will be talking about branching, pull requests, testing, and the README. First, we will talk about the README. The README is important to any repository on GitHub because it lets people know what the project is about, how they can contribute or use the project, and identify its features. For the ServerMatch README, we used our executive summary that we had written for our documentation of the project. This summary explains that ServerMatch is a less daunting point-of-sale system. With over 2.6 million people working in the food service industry, we believe that ServerMatch is a solution that will improve efficiency and improve server-customer interactions while cutting down on the necessary time it takes servers to navigate through a POS system. We then go into some details of ServerMatch's features, which make it unique from other POS systems. The next few slides include screenshots of our ServerMatch app. This slide includes screenshots of a login and setup restaurant pages, as well as the navigation bar. For the login page, you can either choose to log in or view the setup restaurant page, and in the setup restaurant page, you can set up a new restaurant or choose to go back to the login page. In the navigation panel, you can navigate between the restaurant menu, frequent customers, add customer, add menu item, and log out. It also displays your restaurant's name and contact information. The first screenshot on this slide is the restaurant menu. When you click on an item, it opens up the menu item page, which is shown in the second screenshot. This menu item page includes a larger version of the image, its title, its price, and its description. The third screenshot is of the Add Menu Item page. When adding a menu item, you are required to add the item's title, price, description, and image of it, and select whichever filter bubbles best describe the item. The last screenshot is of the filter menu page, which you can access by clicking the yellow plus button in the restaurant menu. This allows a server to filter the menu by its item's contents. The first screenshot on this slide is the frequent customers page. Adding frequent customers was a decision we made in order to make the server-customer interaction more personalized and more efficient. When you click on a customer's name, it then opens up to the second screenshot, which shows their order history and frequently purchased items. The last screenshot on this slide is the Add Customer page, which requires you to add in the customer's first and last name, their phone and email, and choose if they would like to receive receipts by text and/or by email. This slide includes screenshots of the bill and checkout pages. These two pages are very similar because they list the items you will be purchasing, including how many of each item and their cost. A running total is also included on both pages. The checkout page is a little different because the customer's phone number or email is required in order to send out a receipt. Next, we will be talking about branching. Branching is when you create a new test branch separate from the master branch to work on. These are the 3 steps we use as a team for branching. First, every developer has to check the GitHub page to make sure their branch is not behind the master. All changes need to be up to date. Second, in order to be ahead of master, each developer needs to commit and push all of their local changes on their test branch. Third, they then pull and merge all changes from master to catch up. Next, we will be talking about pull requests. Creating pull requests is our way of checking each other's work on our test branches before we decide to merge them onto master. These are the 3 steps we use as a team for pull requests. First, all pull requests must be tested and approved by a developer other than ourselves. Second, pull requests must be reviewed in a timely manner of 1 to 2 days to make sure we don't hinder any progress. Third, if a pull request still needs some changes made to the code, the developer reviewing it can add comments to the affected lines of code. Lastly, we will be talking about testing. Testing is when the developer who is reviewing a pull request tests out the code in your branch in the app itself. These are the 2 steps we use as a team for testing. First, testing is done by another developer other than the owner of the test branch. Second, after testing is done on that branch, the pull request can be accepted and merged onto master if it is complete and successful.
Hi, my name's Andrew, and I'm going to talk to you guys about Firebase in our app. For our app, we use Google's Firebase, which is a NoSQL and real-time database. And with Firebase, we also use Google's Cloud Storage, which is a RESTful storage web service for storing and accessing data on the Google Cloud platform. Here, we have a screenshot of the data used in Firebase, and it shows user information such as the email used to create a restaurant, as well as a restaurant owner's information such as their email and phone number. Here we have another picture of the Firebase data, and in the screenshot you can see the menu item, and we can see the descriptions we had for that menu item. So the item cost, the description of what was actually on the menu item, the name, the quantity ordered, and as well as the tags associated with that menu item. Now I'm going to talk to you guys about Firebase authentication. So for our Firebase authentication, users will need to set up their account. So first they'll need their own restaurant name, they get to choose an icon for the restaurant, and then they'll have to include a password and an email so they can log into their account with. And after that, users can log in with the credentials that they have previously set up. Next, I'm going to talk to you guys about our project statistics and metrics. First, we're going to talk about GitHub statistics, and we're going to start with traffic and code frequency. So starting with GitHub traffic, our project had 74 views, 40 pull requests, and 30 branches over the course of this project. Here we have a graph of our GitHub code frequency, and this will show us the additions and deletions of the code written per week. So as you can see in the very beginning of our project, we would have a lot of additions and not that many deletions. And then throughout the middle of our project, where we would fix up bugs that we had, our deletions grew over time, as well as our additions. And near the end of our project, as we cleared up and removed some issues and bugs we had, we can see deletions get smaller over time, and additions it still outgrows the deletions. Next, I'm going to talk about some Firebase statistics in relation to the database usage and the storage usage. So here, this graph shows our Firebase database usage. So the one on the left shows that within 1 day, we had 80 reads. And on the right, it shows our monthly usage. It says we have about 16,000 reads. And as time went on in our project, as we got more comfortable with Firebase, our reads definitely increased from the beginning of our project. So here this shows our Firebase storage usage. And on the left, we can see this is over a single day. And it started around 28 megabytes and it ended at 33.8 megabytes. Then on the right, we can see monthly usage. So when we first started database, you can see there's a flat line. We haven't uploaded any data. Throughout our project, we got up to 38 megabytes. And then as we needed to add and delete some data, we went back down. And then as we added more data, we ended up at being 33.8 megabytes.
Hey guys, I'm Brandon, and I'm going to be talking about the app statistics of our application. This includes the memory, frame statistics, and network info. Alright, so our app memory, if we use ADB, since we are running an Android app, we can see how much memory it takes. So at the bottom here, you can see the app memory, the Java heap, native heap, all these statistics. We account for this, making sure it's optimized for any user to ensure that they have a seamless use overall. Moving on, we'll be talking about the frames. This is talking about GPU of the phone. So we can see about 16 megabytes is used for the app, and in between that we want to make sure that it's buttery smooth in between transitions, in between pages, exiting and closing the app. Here we can see in Android Studio, if our app is plugged in and running currently, we can see any changes that are made on the app and how it reflects on the phone itself. So we can also see the CPU usage right here, the memory usage, as well as the network and energy usage. At any given point, if anything changes in the app, it will reflect in the graph. Right here we have memory, and see how it's going up. Well, that might be because we're loading a file onto the app, perhaps an image, or over here, the network. We can see a upload and energy usage right here. This is simply just if something is currently happening in the app. It's your regular tap, touches, drags, scrolls. Here we have our network info, sending images. So in blue here, we are sending an image, and per second we reach a peak of 500 kilobytes. So we do our best to compress the image and make sure that it stays small, so we save space on our Firebase server. And in yellow down here, we are receiving bytes back from the Firebase server, indicating that all went well. Next, we're going to move on to the demonstration of our application. Now we're going to look at the Sprint 3 demo. First, we're going to load up the app. It's got a little splash screen, and if a current is already signed in, we're going to go ahead and display their account, what they already have set up, and we can go ahead and log out of the app. Then, to show that it's still there, we're going to go ahead and log back in with the same user, andrew@gmail.com, with their password, and these are registered on our Firebase, and we keep track of our users. And then, see, as you can see, it's all the same. And we're going to go ahead and check out the frequent customers. Let's go ahead and check out Anthony Macklin. He has these items as his favorite frequently ordered items. And we're going to go ahead and check him out right now. So he ordered a beef burrito. We're going to pass in his email, and we're going to go ahead and save it to our Firebase. Next, in Sprint 4, it's similar, the same thing, where we're going to do the same thing. We're going to log into our app. We're already logged in. And then we're going to go ahead and sign out, confirm our logout. Then we're going to go ahead and sign back in with the same registered email and password. All right, and now we got our app loaded. Same menu items still showing up. Then we can be able to filter items. So we want to look for items that only contain beef. Well, here are 4 items. We can reset our tags, choose any of those that we select. and then we'll check out a customer once more. So we're going to check out Anthony Macklin. And he's got a beef burrito. We're going to go ahead and pass in his email. And we're going to actually, this time, we're going to send him a receipt. And we're going to go and see it in a separate email app, excuse me. All right, and Anthony got an email from our ServerMatch. So his beef burrito. Next, we're going to talk about the sprint process and statistics. Here you can see our sprint hours. On average, we reported 2 hours per sprint, with our mode being 0.5, our median 1 hour, and our standard deviation 2.16. Here we can see our code content for our finalized product. Our user interface consists of 1,413 lines of code. Our models for our app consists of 422 lines of code. Features are 1,786, and our utility help classes consisted of 1,668 lines of code. So we have our sprint burn down charts here for sprint 3 and sprint 4. We can see in sprint 3 that we spent more time than we ideally were supposed to for the sprint, and with that it reflected in less time spent overall in working in sprint 3. The same trend can be seen in sprint 4, where we spent more time in the first half of the sprint, and then in the end we spent less time. Next, I want to talk about how work was divided. Our app had different categories of work, different aspects that we divided into each team member and assigned them to that task and played to their strengths.
Hello everyone, my name is Juan, and I'll be going over this presentation's closing remarks. This includes bugs report, future enhancements, and lessons learned. Let's get started. Alright, so first we will be discussing bug reports, what bugs we ran into, the process of documenting, and how we went about fixing these issues. When creating ServerMatch, we ran into a number of bugs, some major, the majority minor, and most we were able to fix. To name a few examples, these included filters not saving their state, action bar updating with the wrong text, duplicate tags in the Firebase, duplicate menu items in the Firebase, and application crashes. To document these bugs, we utilized GitHub issues. The process we used to report and solve a bug was pretty simple. First, we need to document the bug by providing a short description of the problem and how to replicate it. If unknown, we ask the user to recall their last moments before the bug occurred. Second, we searched the code in an attempt to find the root of the problem and did research on how to fix it. Finally, we implement a fix that removes the bug and after some testing, resolve the error and document its fix. Next up, we'll be discussing the future enhancements that our group would have liked to implement into the ServerMatch application, both if time had permitted and if we were to scale this up to a commercial product. The majority of these enhancements are simply to make ServerMatch more available and more accessible. In terms of availability, we can meet the market's expectations by expanding ServerMatch onto other platforms such as iOS devices, by supporting larger screens for tablets, and through a web application for browsers. For accessibility, we would have liked to add color themes, either for customization or for accommodation for our colorblind users. And also, we would like to give the user the ability to change the text font if they so wish. As for additional features, we would have liked to implement application payments, printer connection for receipts, and also non-server checkout for ordering. Finally, this project served as a great learning experience for everyone involved. I'll be going over what we gained from this both as a team and individually. As a team, we learned how to implement Git and version control into a project that allowed us to efficiently work together remotely. A big part of what was able to make the functionality of ServerMatch possible was the linking of Android application to a remote database by using Firebase. Howard played a big part in implementing this initially, the process becoming faster when more group members were able to learn this to help. And of course, we all picked up a good amount of experience that can be applied to software development as a whole. These include pair programming, which allowed us to combine prior knowledge of each individual of certain aspects to get work done effectively and with less bugs as a result. And also to break down software from the conception to user stories. That was then used to divide responsibilities among each other.
The two main things that I learned during the software development process were following MVVM architecture, because the importance of following this separates the concerns for all of our functions in our development. The second thing I learned was to document our project effectively so that any reader can just pick up our software documents and learn about how our software process worked.
This is Andrew. Throughout this project, I learned how to work as a team using the Agile Sprint framework, and I also learned a lot about the MVVM architecture.
Brandon here. Also, I want to add that I learned how to work and deal with NoSQL database. Also, I learned a lot about working with Android Studio and GitHub.
Hi, I'm Skylar, and two things I learned during this project were how to use Android Studio and GitHub more efficiently, and how to operate using multiple fragments and activities in a single app.
Lastly, the two things I learned during the duration of this project was how to work in a timely and efficient manner utilizing sprints, and since I came in knowing nothing, I learned how to make a working app in Android Studio while using software architecture. This concludes our presentation. If you have any questions, please leave them in the comments below. We would like to thank you for your attention. Goodbye, and take care.